All right. Hello, everybody. Thank you for watching. This is Working Effectively with Cloud SQL on Kubernetes. My name is Compton. I'm a developer relations engineer at Google, and I work on Google Cloud Platform, in particular Cloud SQL. A big part of my job is about making the developer experience for Cloud SQL better. And a part of that is I'm a maintainer of the Cloud SQL Auth Proxy, which is an open source library written in Go, which we'll be talking about a little bit later on. Anyway, so the title again is Working Effectively with Cloud SQL on Kubernetes. And when I say Kubernetes, I'm going to be using GKE in my demo. And for the most part, the two will be interchangeable, but nonetheless, I'll be using GKE. So this talk is broken into two parts. First, I want to give you a conceptual overview to understand what pieces that we're talking about here and how they all fit together and the various nuances involved. And then second, I want to give you a demo of Cloud SQL on GKE, just so you can get a sense of what it's like using it, using all the pieces together. So with that, let's get started. Now, for the conceptual overview part, there's really three pieces that I want to talk about. I want to talk about connecting in general to Cloud SQL, because there's a little bit of nuance there, and it's worth understanding all the various pieces and the recommended approach. Second, I want to talk about what it looks like to do load testing so you can better scale your instance. As you're getting started with Cloud SQL, one of the first questions you have to answer is, how much CPU and memory do you want to give your database? And sometimes it can be a little bit difficult to understand what a good value there is. Now, I should add, whatever decision you end up making, you can always change it. This is not a decision set in stone, so you can change it. Nonetheless, using load tests can help inform that decision so you get up with a good default. And then finally, I want to talk about configuring connection pooling. And I don't mean application-side connection pooling. I'm assuming that all of you in your applications are already using some kind of connection pooling library or whatever. The connection pooling I'm talking about here is a dedicated connection pooler. I'm going to be using Postgres for my demo. And so a great connection pooler to use is PG Bouncer. I'm going to be showing you how to set up PG Bouncer with Cloud SQL on Kubernetes. So for those of you who in the audience who maybe don't know about Cloud SQL, let's just make sure that we all know what Cloud SQL is. Cloud SQL is Google's fully managed relational database service for MySQL, Postgres, and SQL Server. Now, as an application developer, one of the greatest things about a managed service is if something goes wrong, you're not going to be paged. It's going to be the Google SRE team that's going to be paged to fix the problem. And so there's a 24/7 Google SRE team that backs Cloud SQL. And for me, as an application developer, I feel like that's a really compelling reason to use a managed service. Finally, here is the link to the documentation. If you want to go learn more about it, there's a lot to read there. So let's talk about connecting to Cloud SQL in general. Now, if you've ever used a database before with your application, I imagine most of you have. I was thinking when I first ran into this problem, like, shouldn't this just be as simple as I've got my app, maybe I configure a connection string and an environment variable or something, and then I'm connected to my database, right? On the left, we've got GKE, and on the right, we've got Cloud SQL. Like, shouldn't it just be this simple? That was, I think, my first impression, and a lot of people, I think, come to Cloud SQL with the same impression. But in fact, that's not what we recommend. We recommend that you use a library called the Cloud SQL Auth Proxy, or the Cloud SQL Proxy, as it's also known. And in fact, what that looks like is, in a deployment, you've containerized your app, and next to your application, you're running the Cloud SQL Auth Proxy as a sidecar. And so when you want to connect to the database, your application connects to the sidecar, and then the sidecar, the Cloud SQL Proxy, does all the work to connect to the database, and then all the traffic is relayed back and forth through that proxy. And that, in fact, is the recommended way. Now, there's a lot more to connecting to Cloud SQL. There are many alternatives here. Obviously, this isn't always going to work for everybody, and so it's nice to have options. And if you want to know more about that, a great talk to watch is Connecting to Cloud SQL from Kubernetes, done by one of my teammates, Curtis, done at Cloud Next, I think, last year. So I'd point you to this talk if you'd like to know more about connecting. And then finally, there's a whole page just about connecting generally on the doc. So if this is a problem that you want to know more about, those are two great resources that you can learn more. So you might be thinking, why do I need a proxy? It's a very reasonable question to ask. And in fact, it's a question that comes up quite a bit because, again, I think most developers, myself included, when they first come upon this problem, they think it should just simply be a matter of configuring a connection string and then you're connected, right? Like, why do I need a proxy? Well, to understand why you need a proxy, it helps to look at what's happening here in the connections. Now, again, we've got GKE on the left and Cloud SQL on the right, and the box here represents a deployment in Kubernetes land. Now, I should stop and say, if anyone in the audience isn't already familiar with Kubernetes, I'm not going to be going into the basics here. I'm going to assume a basic level of understanding of Kubernetes. So with that said, in effect, what we're looking at here is we've got a deployment. Inside our deployment is the app and the sidecar. Now it helps to look at all these arrows here. So let's look at this first arrow, the application connecting to the sidecar, the proxy. Well, with the proxy, you immediately get authorization. And what that means is the application, through some mechanism, has been granted the explicit IAM permission to connect to the database. And the proxy verifies that the application does in fact have that permission. And it does it through IAM. And that has all the niceties that come with being able to manage permissions through IAM. Now, I should add that the actual mechanisms that we're talking about here are alternatively workload identity, or perhaps you're using a service account key file. And nonetheless, that's how that works. Now, the second line here that's worth thinking about is this one here in the middle. What's nice about using the proxy is that the connection is encrypted. Once upon a time, it was fine to send data back and forth to the database. It was over an unencrypted connection. But nowadays, you really don't want to be running any kind of production workflows that are talking to a database over anything that's not encrypted. And the proxy provides that for you. So those two features together, I think, make the proxy a compelling reason or a compelling tool to use. It gives you security and authorization right out of the box. Now, the second thing I would like to talk about here is just generally about how to think about sizing an instance and how to do so relative or using load testing. Now, load testing is a big subject. There's a lot involved to it. I'm not going to give a holistic view of the whole field. Anything I'm going to say here today is not going to be earth-shaking. I just want to give you an understanding about how to approach the subject generally and some good tools to use. So some of the knobs that you might consider as you're load testing is what kind of configuration does your application connection pool give you? I mean, there's all sorts of configuration values that you can set, and they're worth exploring at depth when you're running across problems here. Another thing to consider is the underlying infrastructure. And sometimes just giving your underlying GKE nodes some more CPU and memory can make a big difference in your throughput between your database and your application. Next, another thing to think about is that there's a number of approaches when you when you get into load testing. The question is, do you want to know just about a particular endpoint? Do you want to know about a user journey through your application that hits maybe a number of endpoints? There's a lot of ways to approach load testing, and it helps to start upfront knowing what question that you're seeking to answer and framing that question as clearly as possible so you know how you want to load test your application. Another thing is the Cloud SQL machine type. The bigger the machine, that means more connections you get, more memory, more CPU, and more performance. Obviously, you don't want to turn up the knob too far, because the more you turn it up, the more it costs. So you have to figure out what the right value is that balances between performance on one hand and cost on the other. And there's lots more. For instance, query tuning is another thing worth considering. Are all your SQL queries written efficiently? Are they doing only as much work as they need to and no more? And the list goes on and on. Now, what makes things a little more complicated is that when you're looking at load testing, an approach that might work for one application doesn't necessarily work for another. So it's important to understand that with all this load testing, the things that I'm going to show you here, your mileage may vary. So it's important to think exactly what question you want to answer, what kind of values you have to change or that you might want to change even, and then finally, how you're going to react to those load tests. So of all these various things that we could be talking about when we're talking about load testing, in particular, I want to talk about Cloud SQL machine types, or how much memory and RAM do you want to give your instance, sizing the instance as it's called. So there's a lot of great tools out there for load testing. One really nice one is Locust. It's a tool that allows you to simulate user behavior. So if the load test that you're seeking to run is more about understanding the path a user might take through your application, first they do this and then they do that and then they do some other thing, and you want to understand in aggregate how is your application performing, Locust is a great way to do that kind of test. Now, if you just want to know about how a particular endpoint in your application performs, or maybe a few endpoints, Hey is another fantastic alternative. It's a CLI tool, and it allows you to put load on a particular HTTP endpoint. Now, for a lot of our applications that maybe have lots and lots of endpoints, it's often the case that only a few of those endpoints are in fact the ones that get a lot of traffic. And so for those, when you want to understand how those are performing, Hey is a great tool to use. And it will be the tool that I'm going to demo today. Now, the final important piece that you want to have as you've decided how you want to approach your load test, the tool that you want to use, the final piece is, how do you measure the results? Now, obviously, Hey, in our demo, you'll see we'll be reporting how it's doing as it goes. But another important piece is just looking at the performance of your database. And so for that, cloud monitoring is a nice tool. You can set up a dashboard. Here's an example, for instance, of a couple metrics where you can look at, for instance, the number of connections, the amount of memory used, and the amount of CPU. There are a lot more metrics that you can look at, obviously, but for me, like those first three are a good way to start. You'll understand a lot of your initial bottlenecks just by looking at number of connections, amount of CPU used, and amount of memory used. So the last thing I'm going to show today in the demo that I want to spend a little bit of time talking about beforehand is the topic of configuring connection pooling. Now, here's the recommended way. You have your application, it's talking to the sidecar, the proxy, and then that's talking to the database. And that works very well for a long time. Now, one of the things to be aware of, though, is ultimately the connection or the database that you're using has some kind of upper bound on the number of connections you use. So there's a page in the Cloud SQL documentation that explains the quotas that are available to your databases relative to sizes. And you can see here that there's a growing number of sizes. You have more memory, you have more connections, maximum connections. Now, one of the things that's important to keep in mind as you're looking at these values is that this, for instance, the top database, 25, is not the number of connections that your application is going to get, because Cloud SQL, the managed service, reserves up to 6 connections for its own use. So as you're doing your load testing, it's important to keep that in mind, that you're going to be hitting some value slightly underneath what the maximum connections are. So let's say you started with a recommended way, you've scaled your app up, things are working great, but eventually your application gets to something that looks like this. You've got a ton of application instances or replicas, and they're all trying to connect to the database. Now at this point, you've probably got connection errors. You've got applications who are unable to get a new connection. What do you do at this point? Well, the thing you can do is you can run the proxy as a service. Now, I should say proxy as a service is not exactly the right way to put it, because you're never going to be running the proxy as a top-level concern. The proxy is always going to be running as a sidecar. Nonetheless, proxy as a service is kind of a shorthand for that. Before I go any further, though, I want to make a clear warning here. I think a lot of developers want to have a really good application that's scalable and has a lot of options for growth in it. But you don't want to start with a connection pooler until you know that you absolutely need it. And the reason for that is running the proxy as a service is complicated. And this is complexity that you really don't want to undertake. Like, you really want to offload as much of that complexity onto the managed service as possible. So don't go down this road lightly. Make sure you have a reason to go down this road. Let's look into why. Why am I giving you this warning? Well, there's a number of reasons, but a few of them that stick out are, for instance, as you're thinking about the connections, you've got your application to the connection pooler to the database. It's now going to be your responsibility to secure the connection from the application to the connection pooler, which now means you have to manage certificates, which is a little bit complicated. You've also got an increased or a potential of increased latency. In effect, what you've done is you've inserted another hop between your application and the database. And the connection pooler and the app might be living on different VMs, different zones. So you really don't want to, you don't really go down this road unless you know what you're doing. Another thing to consider is you don't want multiple applications using the same proxy. What you'd like to do is have a proxy for each application, which means you're deploying multiple connection poolers, you're having multiple certificates, and lots of latency, potentially lots of latency problems to consider. So the list goes on and on. So this is not to say this is a pattern you should never use, but I just want to make sure that everyone understands that you don't want to be going this route unless you know you absolutely need to, because there's some work involved. So with that said, let's look at actually how it works. So in effect, what you do is you've put your connection pooler in between your application and your database. This is traditionally the case. And in this case, like I said, I'm going to be using PG Bouncer. So you can see here that the application on the left side is going to be connecting to a PG Bouncer service, which then points to a PG Bouncer deployment. And in the deployment, you're doing something a lot like what you did when you were running the proxy as a sidecar with your application. You got PG Bouncer as the main container, and then you got the Cloud SQL proxy that PG Bouncer is pointing at as a sidecar. And then finally, the proxy will do all the work back and forth to the database. Now, if you look at the path from left to right, one of the downsides of this approach is immediately clear. Like out of the box, the connection from the application to PG Bouncer is not encrypted. So that's up to you, the application to developer, to fix. Now, PG Bouncer is a fantastic piece of software. It's totally doable. You can definitely configure certificates. You can make this connection encrypted, but it's something you have to do. Finally, when you get from the proxy to the database, you're back on the encrypted path and things are okay. So with all that said, I'd really like to give you a demo of how all this works. I think it helps to just see what it's like in action, and it's nice to see how the pieces fit together. So I'm going to switch here over here to Cloud Shell. This is, I'm running this out of my own account here. And I want to show you first just what it's like to get a simple deployment up and running. So if you see here, I've got no deployments and I've got no services. There's not really a lot going on in this cluster right now. So I have a number of sample code here that I use to work with the proxy. And I've got a deployment and service. Now, before we look at this, I think I'm going to go ahead and just kick off a deployment here. So it will take just a moment. So we'll look at the details as we set these off. Let's get the service going. All right. So the first thing here, this is the connecting part. How do I connect my app to PG Bouncer? So a lot of this is standard boilerplate at the top here, but I want to show you two things. First, we have our application here. I've containerized an application and I'm referencing it here. I'm connecting to the database using the very typical database environment variable. So you can see we're pointing at localhost. I've got my user, my password, both of which are sourced from a secret. And then finally, I'm porting at port 5432, as if I were running this container on my local machine. Now, the next thing to note is I've got the Cloud SQL proxy running as a sidecar. And you can see here that here is my connection string. So I'm pointing to a particular database instance, and I'm starting a listener on port 5432. Now, let's look at the service real quick. The service is pretty standard stuff. You can see I'm deploying a load balancer that's going to be listening on port 80, and it's pointing at my application, which is listening on port 8080. So then let's see how these deployments are doing. So I've got my deployment up. Let's see how our service is doing. There's my service, and you can see I've got an IP address. So let's go look at that. So here is the sample app. You can see this is a kind of a joke. It's a voting app. You know, what's the favorite white space delimiter out there? What do people prefer most? What's nice about this app is it demonstrates what a read from a database looks like and what a write looks like. So you can see I can vote for my favorite white space delimiter. And at the same time, in addition to showing aggregate votes, it's also showing recent votes. And with that, that's really the basics of connecting to Cloud SQL. And that alone will take you pretty far, honestly. Running your container or running your application in a container with a Cloud SQL proxy as a sidecar. So the next thing I want to show you is I want to show you what load testing looks like. Now, prior, I've already installed Hey on my machine here. And let's see here. Let's start with this. Now, there's a few flags that I want to point out. Hey is a really neat tool, and I want to show you some of the flags that you can use as you're doing your load test. So you can see here, by default, if we just run a request like, let's see here, this, not that, Hey. By default, a request looks like this. You point at some endpoint and you provide Hey with a number of flags. The defaults are pretty reasonable though. So if you want to, let's look at what some of those flags. I want to point out a few of these flags here. First of all, I'd like to point out By default, Hey will run 200 requests, and it's going to use 50 workers. And what that means is Hey is going to spin up 50 different workers, and each of those workers is going to be sending HTTP requests to the endpoint in question as fast as possible. So that's a nice way to see how your endpoint can handle some traffic. The final flag here I want to show you here is, so we've got N for number of workers, C for, or rather N for number of requests, C for number of workers, and finally Q for your rate limit. Let's see here. I'll get out of this here. And let's see here. So as you're getting started, it helps to, maybe only throw one concurrent worker just to make sure that all your connection pools have active connections and that all the kind of overhead from establishing those connections is handled and your application is live and ready to go. As you go from there, you can then kind of slowly turn up the knob to, whatever values make sense, whether you start 1 and then increment by 5, or maybe you're doing orders of magnitude. I mean, there's a number of ways to approach this. Now, because the workers are going to be sending requests as fast as possible, sometimes it's helpful to use the Q flag here to rate limit how fast those workers are going. So for instance, I might say, I want to see how my database does, or my application as a whole does, when I send 10 have 10 workers sending requests as fast as possible. And maybe I want to rate limit them to 50 requests per second, for instance. So we'll get that running. That will take a little bit of time to run here. And while that's running, I'm going to switch over here to a dashboard. So prior to starting recording, I did some load tests just so you could see what the graphs will look like. So you can see here that as I'm sending requests with Hey, I'm eventually maxing out my maximum number of connections. Now, the metrics you can see in the documentation do take a little bit of time to populate, anywhere from 1 to 2 minutes sometimes. So it's not really a great demo to show you live. We probably don't want to sit here and just wait for the graph to come through. So there's a little bit of work to correlate your load tests with how your database is performing. Nonetheless, though, you can see that in this case, I'm using the smallest database. And the reason for that is just easier to load test because it's easier to find the ceiling and the limit. You can see here that I've already hit the 19 maximum number of connections. And when that happens, the response that the application will no longer be able to sort traffic and start returning 500s instead of 200s. Now, another nice thing you can do here is you can correlate the number of connections with the load. So you can see here on the number of the CPU use on the right here that, I'm kind of getting up there with about 40% when I'm pretty close with 18 connections. And likewise with the memory use, I'm supposed to have about 620 megabytes or so of memory. We're around 384 when we're hitting a lot of connections. Now, in my experience, when you're working with Cloud SQL, one of the first bottlenecks you'll probably hit, especially if you have a smaller instance and you're trying to turn the knob up to find the right size, you're probably going to find that the maximum number of connections is the first bottleneck that you hit. And once you've figured out how to get past that, either by scaling your instance or tuning your load tests, it's only then that you'll begin to see CPU use and memory use potentially spike. Now, this app that I'm showing you is a toy app. There's really not a lot involved into it. So the CPU use, the writes are negligible, the reads are negligible. They're just very simple. So we're not getting a representative test of the CPU and the memory. But nonetheless, in your application's cases, I'm sure that you'll find that particular endpoints actually do use a lot of CPUs. They probably have more involved writes and more involved reads. So with that, let's go back and look at Hey. So let's switch over here. So in this case, you can see that the initial test did okay. We had 10 connections or 10 workers sending 200 requests collectively as fast as possible, where we're rate limiting with them about 50 requests per second in aggregate. You can see we have a nice little histogram that breaks down how things are doing in terms of time, and we have a latency graph. So you can see our P99 latency is 1 second. P95 latency is about the same. Not very good, but again, this is a very small application. We've hardly given any resources at all. But these are some of the values that you can then be tracking, trying to understand, how is your application doing relative to the load you're throwing at it. And then finally here, it looks like all of our responses did in fact succeed successfully. As you're turning the number of concurrent workers up or the amount of requests per second up, you're going to begin finding 500s and non-200 status codes as your application fails to get a connection, which is another thing to guide you as you're working on the load tests. So let's see how our dashboard's doing. So you can see that we've got some more metrics coming in again, but there's still a bit of a lag. And because this last run wasn't nearly as intensive as previous runs, we're still doing okay here. So with that, what I'd like to do here is, let's see here. Let's get back to the next part. All right, there we go. Now I want to show you the last part of the demo. I want to show you how to configure PG Bouncer as a service in Kubernetes. So let's go look at that. So I've got another deployment here. Now, this time I'm not going to go through the exercise of deploying this. This is something that you can do on your own. I just want to show you what it looks like. So first I want to show you what the application deployment becomes. So whereas previously we had our application and our Cloud Proxy sidecar, in this case we don't have a sidecar, we only have our application. Now instead of pointing at localhost, what we're doing is we're pointing our DB host at this internal DNS record that is pointing to a PG Bouncer service. It's a nice feature that Kubernetes provides. The user, the password, the name, and so on are all the same. So really the difference is no sidecar, and instead of pointing at localhost, we're pointing at this DNS record that will resolve itself to the PG Bouncer service. So let's go look at the PG Bouncer service. This is very standard stuff for people who are familiar with Kubernetes. You can see we're just running a service on port 5432 as if it were Postgres. And then finally, let's look at the PG Bouncer deployment. So I want to show you a couple things here. First of all, I've gone through the exercise of containerizing PG Bouncer. It's yet another thing that you have to do if you're going to go this route. And I've put it out, listening, I'm pointing and then I'm configuring it just as I did with the application through environment variables. So I'm pointing PG Bouncer at localhost, using these various secrets and so on. This time I'm telling it that it's going to find the database at port 5431. That way 5432 is available as if it were Postgres. And then listening on port 5431 is the proxy. So this is the last piece, the sidecar, the Cloud SQL sidecar sits next to PG Bouncer. And again, this is exactly like our previous invocation where we're just pointing at our database instance, we're starting a TCP listener, and that's about it. So one of the big things that I haven't shown you how to do here is to configure certificates. You really want to have an encrypted connection between your application and the connection pooler. But I'm not going to get into that right now because we don't have enough time. So with that, I want to go back to the slides. All right, so I've given you a ton of information. It's kind of a fire hose, especially for people who are new to Cloud SQL. If you've already been working with Cloud SQL, hopefully you learned a couple new things. And if you're been using Cloud SQL for long, maybe you didn't learn anything from this talk. But in closing, what I've done here is I've shown you a little bit about connecting to Cloud SQL, the recommended way, and why using the Cloud SQL proxy is in fact recommended. I've given you some tools to use doing load testing and a little bit of idea to how to think about it and how to use cloud monitoring to correlate your load tests with your actual performance. And then finally, I've quickly shown you what it looks like, how to configure connection pooling. Now, a lot of this stuff is really the kind of stuff that you want to look at carefully. So all of these have resources up on GitHub. First of all, the Cloud SQL proxy is at this URL, so you can come file an issue if something's not working the way you expect or you're having some trouble. The example I showed in regards to running the Cloud SQL proxy as a sidecar is also underneath the examples directory on the Cloud SQL proxy. There's a nice README that shows you how to do it. It walks you through all the steps, and it's a nice guide. The next thing, the little sample app that I showed you, the tabs versus spaces thing, if you just want a sample app to be playing with, you don't want to be writing your own app to get started with Cloud SQL, there's this repo called Golang samples under Google Cloud Platform that has a directory for Cloud SQL, and within that you'll find the Postgres example. There's also a MySQL example. There's also a SQL Server example if you prefer those databases instead. And then finally, the more involved piece of configuring the proxy with a connection pooler, I'm presently working on an example for that that's going to be done, I think, in the next couple of weeks. It's going to be living up in the Cloud SQL proxy repo under the examples directory. So if you want to go through this yourself and look more carefully at the details, all of this stuff will be available on GitHub, and you can look at it carefully. So with that, I'm going to close. I'd like to thank you a lot for watching. I hope you enjoyed the talk. Again, my name is Compton. You can find me as Enocom on GitHub. And if you'd like to send me an email and just ask a question or whatever, feel free to reach out over email. And there's my email address. So thanks a lot, everybody. I'll see you next time.